In numbers 20 and 21, we get to put together a bunch of things that we learned as we work through the idea of graphing. So we want to graph the following functions. Even gave you a little bit of a hint here. Use the rational root theorem, synthetic division, and or factoring to find zeros. Use end behavior and symmetry as needed. So let's start here. We have this equation here that we want to graph. It doesn't look like we can factor by grouping, so we're going to go ahead and use synthetic division, and to help us we are going to use the rational root theorem, which is the one where we use C over D. So here we go. Our values for C are the factors of the constant, so of 12, plus or minus 1, plus or minus 2, 3 goes into 12, and 4, and 6, and plus or minus 12. And then D are the factors of the leading coefficient, which are plus or minus 1 and plus or minus 3. Oh boy, so we have a lot of possibilities. So all of these over 1 and then all of these over 3. We could think of it that way. So we're just going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And now we want to do all these over 3. So plus or minus 1/3, plus or minus 2/3, plus or minus 3/3. Well, that's 1, so we don't have to keep writing. We don't have to write that again. Plus or minus 4/3, plus or minus 6/3. 6/3 is 2. We already have 2. We don't have to repeat it. And plus or minus 12/3 is 4, and we already have that, so we don't have to repeat it. So these were all supposed to be plus signs, and those are all of our possibilities. Now let's go ahead and use synthetic division to find our first 0. So let's try 1. Let's be hopeful. We're going with 1. List our coefficients. 3, negative 25, 44, and negative 12. Bring down the 3. 1 times 3 is 3, plus negative 25 is negative 22. 1 times negative 22 is negative 22. And then add that to 44 is positive 22. And negative 1 times negative 22 is 22. Minus 12 is 10. Well, that's not a 0, but not completely a waste because we know the point 110 will be on our graph. Let's try negative 1. Bring down the 3. This would be negative 2. Sorry, negative 3, and negative 25 is negative 28. That's positive 28. And 44, oh, that's going to be 72. And negative 1 times 72 is negative 72. Negative 84, so that's really low on our graph. The point negative 1, negative 84. Our graph does go low, but this one's still not going to fit on it. Let's try 2. Bring down the 3. 2 times 3 is 6, and negative 25 is negative 19. 2 times negative 19 is negative 38. Negative 38 and 44 is 6. 2 times 6 is 12, and negative 12 is 0. All right, we found one. So 2 is one of the zeros, which means x minus 2 is a factor. And what we want to do is we want to multiply that by the part that's left. So 3x squared minus 19x plus 6. Why is this a squared? Well, we divided a cubed by just something with an x, like an x minus 2, x to the first, cubed divided by x gives us x squared. Now what we want to do is we want to see if we can factor this even further. So can we? We have a 3x squared. So we would try a 3x and an x. We have a positive 6, which means we need 2 positives or 2 negatives. And we look over here, we want 2 negatives. Factors of 6 are 1 and 6 and 2 and 3. And you can kind of think through that. And it seems like we're going to use 2 negatives. And in order to get to 19, we need to put a 6 here and a 1 here. We check that just by thinking, okay, that's negative 1x. Negative 18x does give us negative 19x. So that is correct. Let's get rid of those. Which means, so this is, we can now write this as y equals this. We use these numbers to find zeros on our graph. So we know there will be zeros at values that make these different factors zeros. So at x equals 2 and x equals 6, those are our two obvious ones. If we need to, we can do 3x minus 1 equals 0, add 1, divide by 3. Divide by 3, and we get 1/3. So x equals 1/3 is another 0. Well, these are zeros, so that means we can graph them on here. 1/3 is right there, 2 and 6. Now also what we want to do is we want to find some other helpful points. This one tells us that the point 110 is on there, which is great because it's partly between two of our zeros. Then we really should figure out what else is going on here between 2 and 6. We can plug in 3, 4, and 5, or we could just plug in 4 to get a rough idea. Let's put in 4. Put in 4, we can either plug it in here, or we can do synthetic. I actually think synthetic is going to be a little easier. I'm going to go ahead and put a 4 in here. I'm putting in blue so it doesn't mix us up later, so we bring down the 3. We got 12, and negative 25 is negative 13. 4 times negative 13 is negative 52, and 8 is negative 8. 4 times negative 8 is negative 48, and negative 12 is negative 60. So actually it looks like this goes off the graph a little bit, down at negative 60. And then we would want to graph this. Once again, I have trouble graphing on these things, but we'll go for it anyway. Actually, another nice one is if you put 0 in for x, you'll get the y-intercept of negative 12. So we actually also have a point about right there. And now I did something very bad right there. I didn't explain why this one's going down and this one's going up. So we notice, and we talked about it earlier in this review, the degree is odd and the leading coefficient is positive. So if we went back to this little chart right here, odd and positive, the left would go down and the right would go up. And so that's why the left was down, the right was up. It also says symmetry as needed. We learned that if all of the degrees were odd, it would be symmetric about the origin. If all of them were even, it would be symmetric about the y-axis. Well, it doesn't fit any of those, so we didn't need to use that.